This is our fourth recording for Intro to Mobile Development. We're going to continue where we left off in our third recording, which was talking about mobile app design considerations. We're also going to look at a different IDE. We looked at Eclipse last time. We're going to look at Visual Studio in Cordova and consider what Cordova is. We'll look at a debugger. We'll look at the assignments that we have due. I also wanted to pull up something from my computer programming 1 course. Now, this course, Intro to Mobile, is not a programming course. If you are curious about some of the concepts we talk about that have to do with programming, like here's one that talks about components of a traditional computer, a motherboard, hard drive, RAM. Go to ucjava.com, okay, and that's my course website, ucjava.com. Okay, if you go there, here we go. And then a lot of the courses that I've taught are located here. So, components of a computer. This is from the first programming course, which I mentioned the course that we're in right now is not a programming course. So I just want to show you what you can access here. When I start the computer programming sequence, I always ask a show of hands who has purchased a computer recently. And oftentimes, maybe 2 people will raise their hands. Then I'll ask who has bought a mobile phone recently, and almost the entire class will raise their hands. And nowadays, a mobile phone really is a computer. The hardware is a bit different, but at the end of the day, it does the same thing that a computer does. It's able to do a lot of simple math equations, but it's able to do them very quickly. And from that, they're flexible. We can program them to do things. So if we consider what a traditional computer has a processor. Okay, so does our mobile phone. It has a processor. It's not this big. The processor for a mobile phone is designed to be efficient and not give off a lot of heat, because heat indicates that it's using a lot of electricity. So less powerful, but a processor nonetheless. RAM, this is a RAM sim that you would find in a traditional computer. We'll have RAM, random access memory. It's memory that helps our phone run while it's on. As soon as we turn it off, the RAM basically goes blank until it's used again. So if you have data that you have not saved, that's in the RAM. When you shut down the computer, you lose that unless you save it. If you save it, you'll probably, on a traditional computer, save to a hard disk. Now, on a mobile phone, it will be an SSD card. Okay, usually an SD card rather, an SD card. So a little bit different because SD card does not have moving parts where a hard drive does. So a hard drive, it has a platter, which is this very shiny thing here. That's made of magnetic material. A spindle, which spins it, a head, and an actuator. And the head is what we'll call a read-write head. What that will do is that will pay attention to the magnetic material on this platter. So the platter is entirely magnetic, and the head can either change the charge of these magnets or it can read the charge of these magnets. Either way, it's going to read charges on, excuse me, charges on or charges off. It's going to read that either way. That's what gives us zeros and ones. Charges on, charges off. Okay. The electrical components here, it's going to be a pulse that indicates on or a lack of a pulse which indicates off. Okay. And that's how electronics work. So why is that important? Well, it's very easy for a computer to convert these on and off pulses, or these zeros and ones, to numbers. Okay, so ignore a lot of this because this is from a programming class, but look at this row right here that I'm highlighting and see that they are zeros and ones. What's interesting is you see that we have the 1 lit up here, 1 here, 1 here, and a 1 here. So what we're looking at is on, off, off, on, off, on, off. The computer reads that as the number 150. If we want to change it, let's change it to 151. Oh, shoot, enable editing. I hate that. Okay, let's try that again. Let's change this to 151. I'm going to put a 1 here, and you see it changes to 151. Let's change it to 159. I'm going to put a 1 here, and it becomes 159. Okay, let's change it to, say, 143. Change this 1 to a 0, 143. Now, how am I doing this? Honestly, I have a lot of experience with it just in teaching. I typically can convert in my head, but that's what a computer is going to do. It's going to convert these zeros and ones, or these pulses of electricity or a magnetic charge or lack of charge, into a binary number or vice versa. So we see that it can also take a number and convert that number to zeros and ones. You see here the input are the zeros and ones. The output is the decimal number. See that? The input are the zeros and ones here. Okay, there we go. The output is the decimal number. Computer can go the other way. Well, if I give it the number 174, in this row here, we should get an identical copy of this row here. So in this row, we took 10, 10, 11, 10. The computer converted that to 174. This row, we're going to take 174. The computer will convert that to 10, 10, 1110. Let's see. There we go. So you see that this row is identical to this row. We're just converting back and forth. In other words, every combination of zeros and ones has exactly one decimal equivalent. Every decimal has exactly one combination of zeros and ones. It's a reversible operation. If I put in here, let's take a number, 37, okay? We see the computer is going to make that 0, 0, 1, 0, 0, 1, 0, 1. Okay, let's put that up here. 0, 0, 1, 0, 0, 1, 0, 1, and we get 37. So that's what a computer does well. But what are numbers? Well, it depends. Numbers could be numbers. That's option number 1. What if we had this? The number 1 equals the letter A. Number 2 equals the letter B. Number 3 equals the letter C. What if we had a map like that? That's what we'll call character encoding. Then we'll say that this number, we should actually translate it to a letter on a map. Okay, then we can take letters and we can make what out of them? We can make words out of them. Okay, and this is how we translate from the world that we know, the analog world, to the digital world that computers know. What if it represented color? What if we said 0 is no red, 255 is 100% red? What would the number 37 be then? Probably it would be a shade of pink. No, I'm sorry. Yeah, maybe a shade of pink. It'd be a dark. Let's see. No red would be 0. 100% red would be 255. Yeah, that's confusing because if we put all colors together, it would actually be the color white. So the lower number we get, the darker the color is. So 37 would be. That's a tricky one. You know what? I don't like that as an example. Let's do this. Let's say we had the number 200. Okay, that's better. I like that better. 200 would be a lot of red. Okay, the number 200 would be a lot of red if it were on this scale. So we can convert zeros and ones to numbers. We can map numbers either straight to numbers, or we can map them to letters, or we can map them to colors. Okay, so that's how a computer system works. When I say we're compiling, what we're doing is we're taking a lot of these words and turning them into machine language, turning them into ones and zeros. But the good news is the compiler does that for us. Okay, so we left off talking about integrated development environments. One of the things I mentioned we could do is debug. And if you're going to become an application developer, this is something you're going to want to learn very well. And again, in this course, you don't need to know source code. So I just want to show you what a debugger does. I'm going to choose File Chooser. Remember, that is the screen that we were looking at where we could pick a picture off the file system. I'm going to right-click up here with any luck, and I'm going to say Toggle Breakpoint. Now, a breakpoint means this is where our program is going to run until it hits this breakpoint, and then it's going to let us take over and watch what happens. So let me go back to my Android emulator. Okay, remember our color search screen here? Here we go. When I choose Open Existing Image, when I choose that button, it's going to go over to this source code here, and it's going to let me watch what happens. Okay, so I'm going to choose Open Existing Image. Okay, and then what will happen is the development environment will tell me, hey, You're running this in an emulator and you've just hit this breakpoint. Do you wish to debug? And I'm going to say yes. What it's going to allow me to do now is look at my source code, but it's going to let me watch it run. This is really, really powerful. And again, if you're going to be an application developer, mobile or not, this is something you really want to get a lot of use out of. Okay, in this IDE called Eclipse, I can choose F6 to execute a line. So I'm going to say execute this line, and I don't know how this shows up on the video, but this is a little green bar. And what we're doing is every time I choose F6, it's executing the next line of code. Okay, it just executed this line right here, and you see current dir. That's the directory, that's the file system that I'm in. It's telling me here that it's going to look in this directory for pictures. And where are we? We are in the directory called M&T SD card pictures. That's the directory that our phone is going to look for pictures. So we're going to look for pictures, okay? And then what it's going to do is it's going to see what files exist there. I'll go ahead and choose F6. And you see in the background, our emulator is waiting for us to continue. So our emulator is letting us run this program. And then finally, I'm going to say, okay, that's good. I'm going to choose F8, which tells it to continue. I've seen what I want to see. So let's go ahead and resume, and we'll let it go. Okay. Now that I've told it to continue, our emulator will show us a listing of the images in that directory. Okay. And once again, I can choose Promo Graphic. And once again, it will go through the same math again. It's going to look at every pixel in that image. Okay, now what's a pixel? A pixel stands for picture element. It's every little dot. So what the program just did, and you see we got the exact same results as before, which I would expect because it's the exact same math. What the program just did is it looked at every little dot here, every little dot, and then it sorted them. And it found the 12, it shows me the 12 that it found the most frequently. So in this image, it showed me the 12 colors that it found most frequently, and it gives me that on the list here. Okay. I forget what other image I have there. I actually loaded these images yesterday. Let's just give it the old college try. Let me see what happens when I pick up this other image. Hopefully it's nothing bad. Oh, I know what it was. Okay, it's a very large image, so it actually takes, yeah, that's a humongous image, so it actually takes it a pretty good while to index. But nonetheless, it'll work. On the phone, it's actually pretty responsive. When you run this natively on an Android phone, it's pretty quick. On the emulator, it's a bit slow, but on the Android phone, it's pretty quick. Okay, we'll let that run. We'll go ahead and let that run. Meanwhile, I'll move that over to my other screen so I can keep an eye on it. Meanwhile, we were talking about what is an IDE. I said Eclipse is the one that I use for Android development, and then Visual Studio is one we use for Windows Phone. Xcode requires a Mac, so I don't have that, not on the computer I'm using here. Okay, so let's take a look at Windows Phone. Wow, Windows. Now see, that's an interesting thought. Why develop for Windows Phone? We might think that probably most people in this class are thinking Android or iPhone, but let me make a good case for you. First of all, we talked about some limitations of mobile development, okay? And one of those is that you have to rewrite the program for every platform that you use. Well, there's something kind of new coming out, and you'll hear a lot of different people. There are a lot of different competing technologies, but there's something called PhoneGap or Cordova. In that case, your application you simply write in HTML and JavaScript, and you can deploy it on multiple devices with very minimal changes. Now you might think, wait a minute, HTML and JavaScript, either number one, I've never heard of that before. Oh, by the way, here's the, oh yes, okay. That's the image. It's actually an image of that is the actual New Year's Eve ball at Times Square. A picture I took when I was down on Times Square, and they are the colors at index. It got a lot of blue because that was inside, and if you look in the background, you see the shading is a very kind of navy blue. Incidentally, think to yourself right now, what is a flower that blooms blue? They're very few. They're very few blue flowers. But anyway, that's the other picture. Okay, so back to Windows Phone then. Uh, we talked about some of the limitations of the other phones of write once for each phone. So Cordova will let us use JavaScript and HTML. And you might think, okay, well, that's just a web page, right? If you know what JavaScript and HTML are, you'll think that's just a web page, right? What's the use of that? Well, the nice thing about Cordova is it provides what's called an API, or an application programming interface, where you can use JavaScript to access things that are part of the phone itself. So take a look at this. One moment. Okay, this is an emulator, but, well, shoot, I can't fit it all. I'm going to have to drag this down just a second. Okay, there we go. This is an emulator, and if you look down here, guess what? It's a Windows phone. Okay, and what we're looking at here is an HTML JavaScript Cordova app. Okay, we write it for Windows Phone. After that, we can take a lot of this app and deploy it on an Android phone and an iPhone and BlackBerry, Symbian, Nokia, whatever you want, with very few changes. Okay, so if I do search by color here, I can click on this button. Okay, from Photo Library, remember how I told you this is one of the things I don't like about the Live Plant Places app? Okay, camera roll. Okay, my camera roll is empty. That didn't work out too well, did it? Let's go back. Okay, let's click here. And now you see, look, see, that's what I want to have. The ability to click on a picture, and there we go. Now, this isn't a live app yet. I don't have it so it actually does a color index, but that's exactly kind of what I would like to have in a photo library. Very, very nice. So all of this with HTML and JavaScript. If you have used HTML and JavaScript before, this might be a very good option. So I didn't answer the question though, why do this? We'll go to GPS. Why do this for Windows Phone? I said that you could use it on any device, right? Okay, so why Windows Phone? Well, I did try this on Android, and it's certainly very possible. I'm going to go back, I'm going to close down this debugger. I did try it on Android, it's very possible, but you have to get the Android environment set up in Eclipse. You have to do some things on the command line. There are a couple challenges. For Windows, it's incredibly simple. You look for, first of all, you get Visual Studio. As a student, you can get that for free through the MSDN Academic Alliance. Okay, so you get Visual Studio. Start with that. Download it, install it. One of those things you do before you go to bed because it does take a little while to download. After you do that, you get Cordova, also known as PhoneGap. You get Cordova for Windows, and it is a single zip file. You drop it in a directory, and that's all you have to do. It's very, very easy setup. So if you would like to, if you have knowledge in JavaScript and HTML and you want to leverage that, think very seriously about doing a Windows Phone app because it's one of the easiest places to do Cordova. Now, what's my plan? Because it's so easy in Windows Phone, my plan is to make the next generation of Plant Places Mobile a Cordova app. Develop it entirely within Windows. Then, after it's fully developed in Windows and after it's released on the Windows Marketplace, then what I'll do is I'll run to UC, where we do have Macs, take that same app, make an iPhone app out of it just by doing a new build, and then release it for iPhone. So it's, that's a very, to be honest, if you do want to do iPhone and you have the same limitation I do of not having a Mac, it's a very viable option. Do a Cordova app in Windows. Go ahead and release it in Windows. When you're happy with it, when you're happy with the quality, go to UC, go to one of the Mac labs, take the same thing, just build it as an iPhone app, release it there. There you go. That way you don't actually have to buy a Mac, but you can still do all of the development on a Windows PC or whatever you prefer. Another consideration for Windows, there are 1 million iPhone apps, almost 1 million Android apps, 100,000 Windows apps. Windows has only about 5% of the market. However, the app marketplace is wide open. So you're going to have a lot less competition there. So let's take a look. This is Visual Studio, which is the integrated development environment used specifically for Windows, for Windows platform. So that we're not looking at an Android app or an iPhone app here. We are looking at a Windows app. They have this thing called Solution Explorer over on the right. And what we have here is a very typical Windows Phone application. The difference is this www folder. Inside of here, a style sheet and some HTML pages. This is the Cordova part. If you take this www folder, you can copy it into an Android Cordova application, and the Android application will be able to run it just as the Windows application does here. So over here on the left, we have our source code, but in this case, guess what? Our source code is simply a combination of HTML. Again, I don't expect that you know HTML coming into this course, but if you do, maybe you recognize some of this. It's a combination of HTML and JavaScript. There we go. Here's our JavaScript. Very straightforward. Let me click on camera. Remember that camera page I showed? Let me see if I can expand this so we can see it a bit better. But you see this file is camera.html. Let me pop this out. Okay, this file is camera.html, and literally, again, it is just an HTML page, but it has JavaScript that's able to access the camera on board the phone. Picture source, navigator camera, picture source type. There we go, that easy. It's really not hard at all. It's just normal old JavaScript and HTML and a little bit of cascading style sheets. Capture photo, here's how you take a photo. Very straightforward. If you don't want to get into a lot of heavy programming, seriously consider this. If maybe you have some app ideas, maybe you just want to mock something up and have someone else do the actual app. It's very worth your while to think, maybe I can do a Cordova Windows Phone app, because it's very easy to set up, very easy to write HTML and JavaScript, very easy to make a running Windows Phone demo very quickly. So a very good option to consider. I'm going to go ahead and shut down the emulator there because my computer's running slowly. But probably throughout this semester, as we get into more of the UI widgets like buttons and text boxes and labels, I will show more Cordova examples. Again, part of it is I am natively an Android developer, and I don't want this to be just an Android-focused course, so I want to show some other options. So I will probably throughout this course be showing some Cordova equivalencies with Windows Phone specifically. Hopefully by the end of the semester, I hope to actually have a Cordova app that I also run in Android so that we can compare and contrast. I have that working now. It's just on two different computers, so it's not so easy to show in a lecture. So I'll go ahead and shut this down. This Visual Studio has a lot of the same features as Eclipse does. It has a debugger, very easy debugger to use. The Visual Studio debugger is very easy. If you're doing any Windows development, for things like what we call C#, probably you'd end up using Visual Studio. All right, so we'll shut that down. A couple good options. Okay, so we were talking about, one moment, move this guy back up. Okay, we were talking about what is an integrated development environment, and we looked at two of them, Eclipse and Visual Studio. We can write our program, compile, turn it into zeros and ones, run the program, as we saw on an emulator, debug the program, very, very good to do that. Many other things we can do. We can write tests for the program, automated testing. One of the nice things we can do is we can package for deployment. That'll take us back to our previous screen where we were talking about deployment. Okay, don't underestimate this one too. This is an important one. If you look at the life cycle of computing, if you look at the history of computing, up until about the 70s and 80s, people who were computer programmers were typically working on mainframes, which were large computers, and you just have kind of a dummy terminal that would talk to it. We had nowhere near the kind of graphics we would have now. Imagine if your interface to a computer was something that looked like Notepad. That's it. Everything was a command. There was no click. You didn't have a mouse. Everything was a command you typed on a keyboard. So it started with that. Then we went to this client-server model, kind of in the 90s, where programs would actually run on a PC, which was really a new concept. This idea that you could run a program on a PC was a new concept. And there were some thoughts like, well, harness the power of the PC and so on and so forth. But the problem was this. With a distributed program where it actually runs on the PC, what if something goes wrong? I used to work in banking, and one of the apps that I supported and wrote was one that was used at car dealerships. And it was what we would call a traditional fat client application. And with a fat client application, it actually runs on the user's PC. And so I would get phone calls, from a car dealership in Toledo where they had something that went wrong. Well, how in the world was I going to help them? It was installed and running on their PC. It became really a maintenance problem. Okay, then we went to the web. Now, the web, what it's doing is all the logic is running on a server that's very easy to control. Very easy to control. What happens is the server just prints out some presentation and that gets delivered down to our browser. Okay? And the presentation takes the form of HTML. But all of the logic, all of the thinking and the source code, that all lives on a centralized server that's very easy to access. Therefore, it's very easy to maintain. As software developers, we got spoiled with this model because if something broke, we just fixed it on the server. There are many times I've made updates to the plantplaces.com website, realize I made a mistake, and I go back and fix it, no problem. Okay. Now, the mobile app came out. In the mobile app, guess what? We're running an application on the user's physical phone, which means we're back to the client-server problem again, where what if something goes wrong? We don't have control over that. Okay, I showed you earlier the Google Play Developer Console. Let me see if I can bring this back up. And I mentioned the life cycle of versions that I have out there right now that we had. The current live version is version 5. Older versions are 4, 3, and 2. Okay, here's something pretty cool. If I go to, I'm going to go to APK. Okay, and I'm sorry, do I want to go to APK? I want to go to statistics. Sorry, I want to go to statistics. Despite the fact that version 2 was only available for from February 2nd until February 26th rather. If I click on your app, let's see. No, I want to go to app version. Despite the fact it was only available for download for a short period of time, and then everybody should automatically update to the latest version, take a look. There are still 12 people on that very old version of Plant Places Mobile. Okay, still 12 people on that very old version. And I can't control that. There are bugs in there that I know about, but it's running on their device. There's nothing I can do. Okay, so I can't access those devices. We have to be very careful then that when we deploy our app that we are triple checking for quality. We're making a good app, because once it's out in somebody's hands, we can try to kindly suggest that they update, but we really can't force this. Here's an interesting distribution. Okay, a couple people in Italy, Bulgaria, Australia, English. I would really like to see the Latin American numbers improve here. That's kind of a goal of mine, because I do have a lot deployed, a lot of plants GPSed in Latin America, and it is a multi-language application. I would really like to see that that number. What is really nice, if we do compare mobile to the days of client server, what is really nice is that when we deploy our mobile app through something like the Play Store, they do give us this very nice console. Okay, it'll give us ideas of who is currently using the app, what carrier they're using. No surprise here, Verizon's on top, very clearly on top. AT&T is a bit lower than I thought it would be. AT&T's tied with Sprint. Okay, that's about where I thought. Cincinnati Bell Wireless, a lot of that's the Zoo because that's their provider at the Zoo. Virgin Mobile, Telecom, Cricket, Idea Cellular. Some of those might be the overseas guests that we have. So who's the carrier? Remember we talked about consider the device. Let's take a look at the device. Uh, wow. Okay. Um, okay, so this is others. The 71 is others. Motorola Droid is by far the top device at 10. That's good. That's the kind of phone I have, so I know it works well there. Samsung Galaxy S. Okay, that one's pretty popular. If you look at the Galaxy S3, 8 and 5, Galaxy Note, and then a few others down there. So we can have an idea of where is our app used. Maybe are we targeting for some platforms where it's not being used. So this does a lot to kind of help us find out who our audience is. It's a very important thing to consider when you're thinking about supporting your application going forward. So some very important concepts. What do you want to do? Where are you going to get the data? What will the screens look like? What devices are you going to support? Which IDE are you going to use? How are you going to deploy? And how are you going to support? We talked, of course, about the IDE and the emulator. We took a look at a couple examples of the emulators. We saw the Windows Phone and the Android emulator both. Programming languages. Here's something interesting. We talked about Android, which is Java, but it's kind of a specialized flavor of Java called Dalvik. Android says it's because it's tuned for the mobile device. So it's not really a pure Java. Look at two of the others, though. Nokia, Symbian. So this is the older Nokia. Symbian used Java. BlackBerry used Java plus extensions. Now the newer Nokia phones run Windows, okay, which is C Sharp. Okay, the older Nokia phones run Symbian. What's kind of ironic and kind of unfortunate here is the most portable, most pure version of Java was on Symbian. So the best as a Java programmer, the most pure version of Java of all these was the old Symbian, but unfortunately that didn't really take off as the other platforms took off. So BlackBerry is a somewhat pure version of Java. Android is a somewhat customized version. So nonetheless, the Java skills are portable somewhat between Nokia, BlackBerry, and Android. If we look at iPhone, it uses something totally different called Objective-C, which is the background for Cocoa. It's a bit of a different paradigm than Java, and that's kind of, for me personally, my experience is in Java development, and I wanted a phone, something I was comfortable with, which was Java. I'm old. I shouldn't say that. I'm just getting older. And as I'm getting older, I'm thinking, you know what? I just want to become an expert in certain things and maybe not jump on the bandwagon of everything new. Windows Phone uses C Sharp. Okay. Now, we just took a look at Cordova and PhoneGap, which is the concept that I showed you where you can write your page with HTML and JavaScript. And it will run on any of these platforms above. So if you don't want to invest a lot of time in a programming language, which is a good consideration, maybe you don't. Maybe you don't. Consider the HTML plus JavaScript there. The only caveat is that you still require that native build. So you still need to put it in the IDE and do a build to get the packaged application like the APK. You still need to do that. But that's the only step you need to do. Everything else, the HTML and the JavaScript, that's pretty much portable across platforms. I think we're going to see a lot more of that because, frankly, developers are getting a little bit weary of writing an iPhone version and then doing an Android version from scratch. It's a lot of wasted effort. I think we're going to see a lot more of the multi-platform. You still have to abide by the quality guidelines of each operating system, but I think we'll see more of that. Okay. So, what platform do you want to develop for? These are some thoughts that I have, and again, I'm a little bit biased. You'll have other friends who will tell you, "Oh, absolutely, you only want to do iPhone, or other friends who might say you only want to do Cordova. Looking at it, at a fairly objective rate, here's what I see. iOS, great user base, very large user base, and they are a user base that expects mobile applications. Okay, so it's a user base that's willing to pay for mobile applications. It's common in the App Store to pay for an app for Apple because, again, as a developer, there's a bit of a cost there. You have a $99 a year developer fee, plus you have to own a Mac, which means you have to buy one, unless you can use one or maybe you already have one. So it's common for apps there to actually cost or raise money some way. Okay. So the minuses are you do require a Mac, and honestly, it's a saturated market. If you have an idea, look in the App Store. Somebody's probably already done it. So it's kind of hard to find a niche. Android. Similar advantages as iOS, a tech-savvy crowd with a large user base. Android users tend to be more accustomed to getting things for free, honestly. I thought about pricing out Plant Places Mobile at maybe $1 a download, and then eventually decided no, I was more interested in getting users to the Plant Places website. That was really the goal. I'd make some ancillary revenue on advertisements. That's it. So, okay, so some advantages: large user base and a tech-savvy crowd. Definitely dominant market share at this point. In America, dominant, about 53% of the market for new devices. Even more dominant if you look at the entire world. Okay, the downside is there are a lot of devices that you have to prepare for. iPhone, not so bad. You pretty much have iPhone and iPad. Okay, and a few versions of those, that's about it. With Android, you have to deal with different processors, different manufacturers, different features, different resolutions, a lot of things you have to consider. Now, all of the others, you have the opposite issue. You have lots of market available. It's not so saturated, but you have all the different platforms to consider. So that's where Cordova really comes in pretty well. I did mention for iOS, there's a $99 a year fee to be a developer. That includes a lot of good support, though. That includes they will give you two options. Now, this is what I've read recently. You might have newer facts than I do, but they will do things like answer questions about development. Android, you're more dependent on the user community to answer questions, things like forums. You can develop all you want. Okay, you can develop, you can find documentation all you want. When you deploy to the Google Play Store, you have to pay $25 one time. Okay, there's a one-time $25 fee to deploy to the Play Store. One nice thing is, though, that's only if you deploy to the Play Store. If you don't use the Play Store, you don't pay the fee. You can deploy by emailing the application around. Okay, that's an option. You can provide a download link on your website. It's actually very easy because an Android phone will recognize the APK extension and automatically it will want to install it. So there are lots of options there. The other thing is with Android, all the documentation is available to you because this fee is only paid once you hit the Play Store. With Apple, when I was preparing some of the slides for a future presentation on app quality, it said I had to be a registered Apple developer. Okay. Before I could look at the quality guidelines, I had to be a registered developer. Okay. So I went ahead and filled out the registration. I didn't pay the fee. I just went ahead and filled out the registration, got an Apple ID, logged in, went to look at the quality guidelines, and it said that my account didn't have authorization to look at the quality guidelines. So in other words, you have to go through the whole process, pay the fee, and then you can see the documents. With Android, you can see all the documents you want. Once you go to deploy, you have your $25 fee. And trust me, it's well worthwhile to use the Play Stores because of the support that they give you when you are the support that they give you when you are when you have the application deployed. Okay, so that wraps up that presentation. Next presentation, I think we'll hold for our next recording because we're already near the 40-minute mark, but I did want to go through and talk about some of the homework. The next presentation is going to be a topic that I really enjoy, usability guidelines and best practices. So we'll take a look at this for next week. Both app stores have a lot of really good information on this. Both Apple and Android have a lot of good information. What I do want to do though is I want to go over, in the minutes we have remaining, I want to go over our assignments. Okay? First one, both I think are going to be fun. And the idea here is that these are learning experiences that you can carry with you into future classes. So, one moment please, I'm pulling it up on my other monitor. Okay, bring it over here. Okay, first one, I want to look at app quality. Okay, okay, quality and usability evaluation, and these are things that we're going to look at in our next recorded lecture. Okay. Now, both Android and Apple have guidelines for quality, okay? And let's take a look. If I look at the Android quality guideline, well, actually, hang on. I'll put this here. Okay, we'll come to that in just a second. The Apple quality guideline, this is the link I was just telling you about. If I click on this, okay, this is the link where you have to be a registered developer. So this is their website. What's really interesting, okay? So this App Store review guidelines. If you click on this, it prompts you to log in and all this stuff. Okay, I tried, and then it told me I wasn't authorized. Let's see if I remember my. It will probably tell me here. Oop, wrong password. Probably will tell me I can't access this page. Why can't I access this page? I guess I need. I don't know. I don't know. What's really funny is this whole page talks about usability, and then it tells me to sign up to look at this link, and then it gives me what I consider to be a not very user-friendly error message when I can't access it. But okay, whatever. I'm not going to worry about that. So, what is funny though is that on this website they have their human interface guidelines, which we're going to go through next week. And they do a really, really nice job here. They have a very well written discussion on how to interact with the user. I really like that. So, and that you don't have to be a developer to access. So we'll take a look at that next week. For Android, I have the link here, Core App Quality Guidelines. So the idea is whether you're iPhone or Android or Windows or whatever you choose to be, look for the quality guidelines. Here we go. And then what I'd like you to do is download a few apps on the App Store, okay, and grade them. So download about 3 apps. Find one that really does a good job of adhering to the quality guidelines. Find one that does not adhere to the quality guidelines, and then maybe just pick another one. So find 3 total. Look at the quality guidelines, okay, cite at least 3 specific references. So here, Core App Quality Guidelines, notice that for Android it has an area, it has an ID, and then a description. So what I'd like you to do when you review these apps is find some of these by ID, by the identifier, find some of these quality guidelines that the app either follows well or violates. Okay. Here's one that I see. Here's one that I've seen before that's been violated. Navigation UX N1. App supports standard system back button navigation and does not make use of any custom on-screen back button prompts. When I first designed Plant Places Mobile, on the web page that shows the details of a plant, let's see if I can bring up a blue plant here. Let's see if we can look at that. On the web, so what I'm going to do while I'm talking, see if these are blue. I told you there aren't many blue flowers. I'll go ahead and click this. We'll see what it does. We know this will give us back, if it can find matching plants, it will give us back a list of plants, and then we can click on that to go to the website that will show us details. When I first designed this, when it went to the web view, yeah, see, there aren't many blue plants. That's the trick with that. When it went to the web view and showed the web page, I put a back button on there because I thought that the user would want to go back. Well, the trick is 2 things. Number one, UXN1 says you can't have a duplicate back button. The user should only use this back button here. Okay, I don't know how that's going to look on the recording. I think I went too low. But anyway, user should only use this back button at the bottom of the Android device. You should not duplicate that back button somewhere else. Okay, that makes sense. I gotcha. Let me click on another blue here. We'll try this one. That makes sense. The other thing is that honestly, if you have another back button, if you write your own back button, you're wasting screen real estate. Go ahead and use the one that they provide. Okay. Another one supports standard back button navigation. That means that you also cannot override that back button and have it do something else. I mentioned an app that I thought I would like, which is Titan TV. It shows the TV listings. For reasons I could not possibly understand or explain, the back button on that Titan TV app does not actually close the app. Very strange. So that's something that's a big UI no-no. Okay, back button should go back on the app. Okay. Okay. By the way, I chose white. I chose the color white, and you see it comes up with a bunch of plants that have a white flower. So I'll go to Exocorda racemosa, which is a shrub that has white flowers, and we see now it's going to open up the web page. See, when I first designed this, I put a back button up here, but that violates that Android rule we were just looking at, which says you can't have a second back button. You have to use a system back button. It also took up a lot of very important real estate. Permissions, request only the absolute minimum permissions that are required. There is one here, and where is it? There's one for orientation. One second. Let me just search orientation. Okay, app supports both landscape and portrait orientations. Okay, app correctly handles rapid transition between display orientations without rendering problems. That's an interesting one. It's one I hadn't really tried until I deployed this on the marketplace. When I deployed this on the marketplace, you have to go through this quality checklist. And honestly, I found a lot of bugs in my own program, and this is one. There were certain screens where if you went from portrait to landscape, it would lose all the information. There's one. I can think of apps I use right now where when I do switch orientation, it stays in landscape mode. So that should be a pretty easy one to find. So as your homework, what I would like you to do, so this is the assignment, but as your homework for next week, I'd like you to read over one of these core app quality guidelines, either Android or iPhone or something else. Next, also look at the UI guidelines, the usability guidelines. And again, Android and iPhone both have usability guidelines. I've posted links here. Both are very good, very well written. Apple's has some great examples in it that I like. So look for violations of usability. This will be very easy to find. I see this all the time. I see apps that make things that are not very intuitive. Okay, so again, with the same three apps that you're grading, look for usability issues. Okay, so homework for next week, read over these usability guidelines. But for this project, which is not due next week, this project is actually due the 15th. For this project, download some apps, give them your own kind of rate on or grade on how you think they did on usability. Now, pick at least one of the three apps, go to the appropriate store, either the iPhone App Store or the Google Play Store, and create an evaluation. Okay, do an evaluation. Go through, you can give it a rating. So give it a star rating. Go through, give it a star rating, say what you think. My only request is don't choose Plant Places, please, because I'm using that as a case for our class. So I'm already showing you what I like personally, what I don't like. I'm sure you have other ideas, and I'd be curious what they are. But just pick an app that's not Plant Places or not one that I've already mentioned. So create a document with this. Also fill out this grade sheet here, and then submit this. It is due on Monday, July 15th. So that is assignment number 1. The next assignment, and this one is due at the end of July. I believe it's, I'm going to say Monday the 29th. is to design and storyboard your own app. We will talk more about this next week as well. But once again, Apple, I have a link here. They have a really nice page that describes app design. Okay, they list 3 steps. I wish I had followed these 3 steps with Plant Places Mobile because I really like the way they discuss this. And again, we'll discuss more of this next week. But the 3 steps that Apple recommends list all of the features the users might like. So think about your app. What are all the features they might like? For Plant Places Mobile, I thought search by color, GPS a plant, view a map of plants, upload pictures. There are a few others that I left off that I haven't done yet. So several features. Think of all the possible features. Number 2, and this is a toughie, determine who your users are. Determine who your audience is. That can be tough because it's easy to make an audience that is too big or even an audience that is too small. Step number 3, filter the feature list through the audience. Take all the features, consider how they apply to your audience, and then create a definition statement. So these are the steps that Apple recommends on this link above. Again, very, very well said, I think. I like the way they did that. Next, get into a storyboard. We'll talk about storyboarding in a future recording, either with the Fluid UI app that I showed you in class earlier, or with PowerPoint, or with HTML, or whatever you wish. Show the screens, how they relate, how UI elements appear on the screens. Okay. Part 3, create an app store description and an icon. Okay, so first the icon. Both iPhone and Android, both Apple and Android, have icon guidelines. Follow those guidelines and make an icon. Okay, you don't have to go all out on this and make something incredibly pretty. Use Photoshop or GIMP, which is open source. It can be as much as a letter on a background. That's it. I mean, like the Plant Places logo, it's pretty simple. Honestly, if you look at most logos, most of them are really simple. You know, if you really look at a lot of logos out there, many times it's just stylized text, that's all. So make an icon. And you remember that I showed you a couple of icons from Plant Places, how there are 4 different sizes: LDPI, MDPI, HDPI, and XHDPI. So consider that, make an icon. Next, make an app store description. And you might recall, one moment, I need to move this just a bit. You might recall I showed earlier the Plant Places mobile store on Google Play. Let's see if I still have that up. Yeah, here we go. Okay. Store listing, here we go. This describes the features. Okay, what's the title? What's a description? Promotional text, recent changes, and then some images of the running app. Okay. So write this for your app. Now go back to part 1, design your app. Consider these 3 steps because that's going to have a lot to do with the description you write for an app store. Okay. By the way, if you don't have an app, just make one up. It doesn't have to be a new or unique app. Just think of something and make it up. But anyway, write that. Here is, so I've put a link to Android's recommendations for writing an app description. I put a link to Apple's as well, and also copied the text here. Again, well written, well described. Take a look at that, and then submit this. I believe the due date is Monday, July 29th. When you submit all this, I also want you to fill out this grade sheet, grade yourself, and then submit that to me, and then that's all used to determine final grades. I mean, that's you know, that will kind of give you a chance to evaluate yourself and give me a chance also to see how you did and maybe provide some feedback as well. So those are our 2 big written exercises, and I believe that's all we're going to cover for this week. So the theme of this week is mobile app development considerations. What's your audience? What's the platform? What problem are you trying to solve? Where are you getting your data? Can you add value by mixing different data together? Can you add value by finding data from the phone and mixing mixing it with data from the web? How are you going to deploy and support your application? How are you going to handle versioning? What is an integrated development environment? Remember, it does 4 things. Think, what are the 4 things an IDE will do? Write our program, or edit it if you wish, compile, debug, and run. With mobile, it will also many times package it for deployment. So those are the lessons from this week. Don't forget to take the quiz for last week's lecture and also submit 3 quiz question suggestions from this week's lecture. So if that's all then, have a nice 4th of July holiday, and I will see you again next week. Thank you.